Have you ever wondered what lies beneath our feet? What if you could dig a hole straight through the Earth? Where would you end up? Let's embark on an imaginary journey to the center of our planet. Our adventure begins right here, on the Earth's surface. As we start digging, we encounter the first layer of our planet, the crust. It's the ground we walk on, the mountains we climb, and the ocean floors we explore. The Earth's crust is surprisingly thin, like the skin of an apple compared to the whole fruit. As we delve deeper, the temperature starts to rise. That's because the Earth's interior is incredibly hot, heated by the leftover energy from its formation billions of years ago. Get ready to explore the hidden depths of our planet and uncover the secrets that lie beneath our feet. The Earth's crust is the thinnest layer of our planet, ranging from about 3 to 5 miles thick under the oceans to a thicker 25 miles under the continents. As we dig through the crust, we encounter different types of rocks and minerals. We see evidence of volcanic activity with molten rock pushing its way up from below. The temperature rises steadily, increasing by about 30 degrees Celsius for every kilometer we descend. It gets hotter as we descend because we're getting closer to the Earth's mantle, the next layer down. The mantle is much hotter than the crust, with temperatures reaching thousands of degrees. Our journey through the Earth's crust is just the beginning. The mantle is the thickest layer of the Earth, making up about 84% of our planet's total volume. It's a region of intense heat and pressure where rocks flow like a very viscous fluid over millions of years. This slow movement is what drives plate tectonics, causing continents to drift and mountains to rise. At the boundary between the crust and the mantle, known as the moho, the temperature jumps significantly. By the time we reach the lower mantle, temperatures can exceed 4,000 degrees Celsius. Despite the extreme conditions, scientists have learned a great deal about the mantle by studying seismic waves from earthquakes. Section 4. The liquid outer core. After traversing the mantle, we reach the Earth's outer core, a layer of molten iron and nickel. Here, the temperature skyrockets to over 5,000 degrees Celsius, hotter than the surface of the sun. The pressure is staggering, millions of times greater than at the Earth's surface. The outer core is a churning, swirling ocean of liquid metal. This constant motion generates electric currents, which in turn create the Earth's magnetic field. This magnetic field acts as a shield, protecting us from harmful solar radiation. The outer core is a crucial part of what makes Earth habitable. Section 5. Reaching the inner core. Finally, we reach the center of the Earth, the inner core. Despite the extreme temperatures, which are thought to be around 5,200 degrees Celsius, the inner core is actually a solid ball of iron and nickel. The intense pressure at this depth, over 3.5 million times the pressure at sea level, forces the iron and nickel atoms into a tightly packed, solid state. The inner core is about 1,220 kilometers thick, making it slightly smaller than the Moon, but much denser. It spins slightly faster than the rest of the planet, rotating eastward at about 1 degree per year relative to the Earth's surface. The inner core, though hidden from our view, plays a vital role in shaping our planet's magnetic field. It provides clues about the early solar system. Section 6. Why we can't dig through the Earth. Our journey to the center of the Earth has taken us through layers of rock, molten metal, and unimaginable heat and pressure. But while we can dream of digging through the Earth, the reality is that it's simply not feasible with our current technology. The heat alone would melt any drill bit we could create, and the pressure would crush any vessel we could design. Even if we could overcome those obstacles, the logistics of removing millions of tons of rock and molten material would be mind-boggling. While we may never be able to physically journey to the center of the Earth, we can continue to explore it through scientific inquiry. By studying seismic waves, analyzing volcanic eruptions, and creating computer models, we can piece together the secrets hidden deep beneath our feet. The Earth's interior is a reminder of the vastness and mystery of our universe.